That we have our branches, we are set to go as far as our main layer of effects is concerned. And now, in order to create the coating of frost that's going to be on top of our original helmet, we need to create a growth solver that's based on our branches. And then we can transfer the attributes from the growth solver to the actual mesh. So let's go ahead and grab our remeshed geo from over here. I'll Control C, and we will create our growing solver over here to the side. We will do an object merge, and I'll paste this here. And really the way that we are going to create this growth solver is in a very simple way. And if you did any of my previous courses, then you are definitely familiar with this technique. And I also have a free video called Attribute Propagation that's available to watch on my website. And I'll provide you with the link to this video in the links file. So again, in this video I go a little bit more in depth into this technique, but what we want to do is just scatter a bunch of points on this geometry and then use our leading points from our branches to spread an attribute across this entire surface. So let's start by doing a scatter from here, and let's use maybe 100,000 points. I'll disable all of these other options. Actually, we will leave on relax iterations, and I'll press D, and let's go to the geometry here and maybe make the point size. Let's set this to the default value of 3. So let's grab our leading points. We are going to use the points of our first branch and our second branch as well. We don't really need to include our third branch because our first and our second branch will give us plenty of information in order for us to do this effect. So I will grab the first branch. Let's just duplicate one of these object merges, paste this here, and I'll duplicate another one, and I'll grab the second branches, and let's paste this here. Okay, so now I will grab these object merges, grab them both, hold down Alt and merge them together. So again, this will be our first branch and our second branch leading points. Now as I'm seeing this, we can probably only use our second branch, but I'll just leave this as it is, because it probably won't harm our setup. So we will need an attribute to transfer from these points over to our helmet points, and we will just simply use the color for this. Let's add a color node here for our helmet points, and I'll set this to black, and I'll copy this over to our leading points, and I'll set this to white. So now let's drop a solver from our first input, which will be our helmet points, and I'll point our second input to our leading points. Let's place this here, and inside our solver, let's pin our viewport at the top level, and also I'll press D, go to my background, and let's set this to a light display. Alright, let's step inside, and we want to do an attribute transfer from our previous frame. Let's drop this attribute transfer here, and we want to transfer from our second input, which will be again our leading points. Let's set the point attribute here to CD, and if I press play, let's see what we get. Okay, so by default all of our points turned white now. Let's adjust this distance threshold. Let's lower this by quite a lot. Let's start with a value of 0.01 and see what this will do for us. Alright, so this is pretty good. Now we are only transferring the color based on our leading points, but what I want to happen is that each time point turns white, then every other point around it will also turn white. So let's go ahead and let's get rid of the black points, so we only keep the white points. So we will do a blast from here over to the side, and we will add an expression here at CD bigger than 0. Let's set the group type to points, and let's delete non-selected. And if I preview this and let's maybe unpin our viewport, here we will only have our white points over to the side. So we can source this inside an attribute VOP. Let's point this to our second input here, and inside this attribute VOP we can do a PC open on our second input, so our blasted white points. Let's point our P to the position on the PC open from where we sample our points, and from the handle we will do a PC filter, and let's grab our CD attribute, which is a vector signature. So now I can plug this inside the CD, and what I want to do here is let's promote the radius to the top level, and let's go up, and this should also be a small value here. Let's try again 0.02, or let's try to match the value that we used here, 0.01. So let's do 0.01, and maybe I'll press D on my keyboard, and let's go to geometry here and just increase the point size a little bit so we can see this a little bit clearer. And I'll go up again, and let's repin the viewport to the top level. So let's step back inside and let's take a look at the result. Alright, so now we have the spreading, and over time all of our points should be able to turn white. We have some missing points over here, and this might be because the radius is not big enough, but we will use more points as our final mesh. So let's go up. For our scatter, let's add another 0 here, so let's use 1 million points, and let's reset our simulation and see if all of the points turn white now. So let's press play, and this will be a little bit slower, but we can see that now all of our points are slowly turning white. And looking at this, maybe the distance now, we can see that these are expanding quite fast, so it's going to outmatch our growing branches. Let's step back inside and let's reduce the search radius even more. Let's start with a distance threshold here. Let's have both of these, and maybe we should actually link these together. So I will copy parameter and link this to our search radius for our PC Open as well. Let's reset the simulation and press play. Okay, so now this is a little bit slower, and it's going to match the growth of our branches slightly better. Let's go up. Let's go ahead and get rid of all of the dark points. So let's do the same thing with the blast node. We'll set the expression here at CD bigger than 0. Let's delete not selected and set the group type to points. So we end up with something like this, and maybe we can template our branches. I'm not sure if we are going to be able to tell how well this works, but let's template this, and we can kind of see our branches, and our growing points are more or less following the growth of the branches pretty closely, I would say. We don't need to be super accurate here, because we are going to do an extra step after we turn our points white, which is to add an age attribute. So this will allow us to fade the color of our points when they turn white. So it's not going to be a completely 0 to 1 transition between the colors. So back in our solver, let's do an attribute wrangle here, and sort of in the same fashion that we did earlier with our emitting points, we will say that if your color, so cd.x, is bigger than 0, then at age will be plus equals 1. So we will start incrementing the age of each point as soon as the point turns white. And if I go up, now I can, let's maybe just do this after the blast node. I can do an attribute VOP, and we can remap this age value. So inside here, I can do a fit range from our age, and let's place this inside the CD. And if I increase the source max, let's maybe promote this parameter. Let's go up. I can set this to a higher value. So let's maybe say that I want to fade this value over a duration of 50 frames. I will set this value here to 50, and I have to reset the simulation so our age is taken into account. So let's give this a second. And now we can see when we have the age, we also have this fading happening over time. So this is the attribute really that will drive the material transition between the original material and the frosted material. And again, if this is your first time seeing this setup for the growth solver, I will recommend that you watch this attribute propagation video, where I go into more detail about how all of this works. So from here we can drop down a null, and let's rename this to PTS growth. And now we can use these points to transfer this age attribute from the points directly on the mesh geometry. But we are going to do this when we get to the rendering section, so it makes more sense as we are building up the material. And for now, we are pretty much ready to take care of our last layers, which will be the snow volume and our snow particles.